Okay, we've already seen the explanation for charged particles traveling in magnetic fields. Here's a system, a setup where we can talk about that and try doing it, see how it comes out. What we have here is an oscilloscope. It's an old one, might be older than me. And what happens in here, in the back, there's a place where there's an electron gun. The electron source is in the rear of this. Electrons would just be spraying out of it, but they're being directed and focused into a beam coming from back to front. So what you see is this dot you see is actually just the result of electrons colliding with that surface from the back of the oscilloscope. So we have a beam of charged particles coming towards you. At the same time, we're going to have some fun with them with this magnet. Now this is a horseshoe magnet. One of these has to be the North Pole. One of them has to be the South Pole. I have a compass, which I'm going to use to determine which is which. This compass, the red painted end of the needle, points towards magnetic north. So let's see which is north. It seems to want to point towards that one, so it better point the opposite way for this one. Okay, good. So this is the South Pole, and this is the North Pole. Now that I know that, I don't need the compass anymore. All I'm going to do now is take this magnet, which is north-south. Now I'm going to set it so that north is on top and south is on the bottom. Now think about the magnetic field. Field lines would be going out of the north into the south. So the field lines are going down. Out in front, there's field lines going from north to south. They're also going down. Out in front, they're all pointing down. Some are only going from here to here. Some are going way out here from here to here. Some are going clear out and through the oscilloscope and down through the table and coming back up to here. So as we go further and further, it's just a bunch of field lines going down. Now, what's going to happen when that field is felt by these charged particles? Now, these are going to be coming out this direction. So we're going to use a right-hand rule here. Index fingers for the current direction. The charged particles are going that way. That's V, your velocity. The field, remember, north is on top, south is on the bottom. So the field is going down. So direction of current, direction of field. My thumb will tell me the direction that the charged particle will be deflected. They're going to deflect towards me. So we're expecting them to travel towards me. They're going to deflect to this side. Watch the dot and see where it moves. So as I come in, it's going to left as you're seeing it. My thumb said it was going to go to the right. Something's going on here. What's wrong? Right-hand rule is for positive charges. If these were protons coming out here, right-hand rule says towards me. The problem is they're not positive charges, they're electrons. So instead of going towards me, they're going to go the opposite way because it's the opposite charge.